الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Good evening and assalamu alaikum. Welcome to another session on Google Cloud on the Al-Ayyam Al-Raqmiyya, Digital Days on MENA. Today we're going to cover another topic on GCP, Google Cloud. We're going to talk about Google Cloud Authentication and authorization for services, application that we run on GCP. So we're going to see what are the options we have in Google Cloud and what are the tools that we're going to be using in order to authenticate, authorize user identities to leverage services into an applications in GCP. Previously, in previous sessions, we talked about a tool called Cloud IAM, Cloud Identity and Access Management, and we mentioned that security always in Google Cloud is two kind of two folds. It's basically a combination, or it is how do you call it? A work of both responsibility of the customer itself, of some of it, and it is a responsibility of Google as well. So there are different layers that are the responsibility of Google, things like where is the services are hosted, the data center where the infrastructure is hosted, the lower level, at the hardware level, things like replication authorization at the layer of the infrastructure itself. But then when you deploy application in Google Cloud, then it will be responsibility of the user to authorize and authenticate users to use the application that are running in Google Cloud. But Google, in that sense, when we talk about Google Cloud, they give us the tools in order to do that. And Cloud IAM is one of those tools that allows us to give a set of permissions to access those resources in GCP. So the way it works, the Cloud IAM, it basically does let you manage that access control by defining what we call members which basically are the identities that you can give access to, and then you give a set of permissions to them, which will come under what we call roles, and each service in GCP will have different kind of roles. So the roles can be the resources can be projects, they can be folders, they can be the whole organization in your GCP, and you can apply those roles in each one of those levels. Now, you can apply very, very broad roles at what we call the project level. The project is, remember, we talked about being the container where you would be able to create resources, where you would be able to, what you would be built for the resources, where you will be enabling those APIs to use them at a project level. So I can give what we call project level permissions. I can give things like a project owner, project editor, project reader. So they apply to all the resources in my project. Now there is tens or even hundreds of resources in Google Cloud. We have what we call predefined roles. Predefined roles are a role-based kind of set of permissions that are given for different services. So if I'm using cloud storage, there is a set of predefined roles according to a particular identity, what they are allowed to do with that service. And it consists of multiple of many permissions that come to be able to allow them to that particular task. And then you might have, for example, the query or computer engine instances. They have also, each of those services, they have a predefined role. So when I decide which particular role I want to give to my identity, which we're going to talk about in a second, I can assign it to those set of permissions. I can assign them to what we call resource. So Cloud IAM policy, it's threefold. It's who the person I'm going to give access to, or the group, or whatever, the identity, can do what, which is the set of permissions that I want to give them. And this will be part of the consisting of those roles that are a set of permissions. And then the third part of it is on which resource. So you can select what resource I want to apply those permissions to give to my identity to be able to do those tasks. And you can grant more granular access to those resources using what we call the custom roles. So those predefined roles are a set of permissions. If they are still so broad for my kind of particular task, of my particular kind of requirement, I can customize them. I can make them more granular to the level I probably remove some permissions. So I can basically be using what we call the principle of least privilege, just giving only grant the access to resources that are necessary to do a particular task. So my identities, they can be a Google account. So anybody with a Gmail account, anybody or any Google Groups accounts, I can go to the console, I can give them access, assign them those permissions. Or if I am what we call a workspace, a part of a workspace domain or a cloud identity domain, which basically any company will have a domain name that is associated with workspace or cloud identity. So there would be like XYZ at theircompany.com, whatever that domain is, and they would be basically associated with the Google accounts. I can associate them with a particular role. And that role, like you see here on the slide, it could be for computer engine, it could be for storage, it could be for PubSub, whatever services that are available, they have this set of predefined roles. And then I would assign them to a particular resource. So this is like the binding of this is what we call an IAM policy. So who has access with the IAM members? Like I said, a Google account that I mentioned, the Google group, a workspace domain, a cloud identity domain, but we have also what we call service account. So a service account is probably going to be more the focus of today, because we want to authenticate applications and authorize them. So service can, like I said, it belongs to an application instead of an individual user. So you can have a virtual machine taking an identity, a particular service account identity, and you can give permissions, assign roles to that service account. So whatever that service account has as permission, I can do with that particular virtual machine, or I can do with that particular associated with a particular application that is running on that virtual machine. A Google group, like I said, is a collection of Google accounts. It can contain service accounts as well. And every group will have any identity, in fact, not just the groups, either a service account or a Google account or anything. It will be identified by an email address. So as soon as I put that email address, that will be the identifier or the identity that I need to give access to in my console in GCP. And these are the kind of the stuff that we talked about previously. And so what resources members have access to? You can get access to users for any Google Cloud resource. So some of the examples I can even give at the organization level, at the top of the hierarchy. I can give them at the project level or at the folder level, and then I can go inside to the particular resources: compute engine, cloud storage buckets, PubSub topics, whatever the resource that I can create. I can set a set of permissions in a predefined role or a custom role to assign them to my members that I mentioned previously. So what does it look like, the operations that allow no resources? So the permissions that are part of that role, basically they dictate what operations are allowed on the resource. In Cloud IAM, in the Cloud Identity and Access Management world, permissions are represented in the form of the service first, the resource, and then the verb, which basically says what is the action. For example, you have here PubSub as the service, the resource would be subscriptions. Consume is basically the verb that I'm going to give. So the permissions usually, not always though, correspond to a one-to-one with REST methods, and this is basically each cloud, Google Cloud service has it associated with a set of permissions for each REST method, like you're going to see in those examples, that is exposed. So the caller of that method needs those permissions to call that method, to call that API. For example, the caller of, let's say, publish needs to have PubSub topics publish permissions. So this is kind of the publisher or the caller is that, so I'm going to assign them that permission in order to be able to do that method. And the role, like I said, a role is a set of permissions. So here we see a set of permissions for instance admin. So they will have, I think it's about 255 permissions. These are the top ones in there. And I can, if I wanted to, customize it more, remove some of the permissions if I don't need them, and give a role a different name and assign it to those identities that we talked about. And the basic roles, like I said, there is some basic roles, or what we call, this is where basically when Google Cloud starts to give to provide a Google Cloud public service. They started with this basic roles, which basically apply at the project level. So, and they basically will be inherited to all the resources inside it. So you've got the viewer, the editor, and the owner. So the viewer, somebody basically with read only to all the resources inside your project. An editor is something with have edit roles to edit permissions to data. They can deploy code. They can add resources, those kind of things. And then the owner, they will have all those permissions for a viewer and editor. Plus, they would be able to give permissions to other, delegate like permissions to other users, and give them permissions as well on different services in Google Cloud. Predefined roles. So like I said, every service in GCP will have predefined roles. So in this example here, we've taken in this particular example here, we see in Bigtable. So a Bigtable as a resource that I need to give permissions to my users, it's got different predefined roles. So an admin, for example, Bigtable admin, somebody who would be responsible to administer all the instances of within a project. If I wanted to assign that at the project level, I've got somebody who's got read-write access, basically Bigtable user, or basically somebody who's just like read-only access to my data. I can give them Cloud Bigtable reader, and I can got three levels where I can apply those. I can apply them at the organization level. So if I give somebody access with this particular role at the organization level, they would be responsible for, if they are Bigtable admin, they would be responsible for all instances in my organization on all the projects. I can, for instance, give them access this particular role at a project level, and they will be basically responsible for all the instances at a project level. Or I can just specify which Bigtable instance I'm going to give them access to, and I assign either admin or user or reader in that particular case. And you can also grant multiple roles to the same user. So that you might have somebody who's got Cloud Bigtable reader, so that you want them just to read data from Bigtable, but you can give them BigQuery, for example, admin. So they were responsible to do more on another resource. So that identity, I can give them multiple predefined roles for different resources if I wanted to, depending on my use case and what that user role is in my organization. And as I said, we do have custom roles as well. So if you need something even finer grained, and you want to remove some kind of particular permissions from predefined roles, let's say this instance admin, for example, like I said, it has, I think, 255 or 266 permissions. So it has the deletes, the add of the disks, anything to do with networking that I need to to be responsible for on a virtual machine. So I can remove some of those permissions and I can create a custom role based on a predefined role, or I can actually do a combination of predefined roles with a specific set of permissions. So let's say if I've got somebody who's dealing with data, for example, and they are working on Bigtable and BigQuery, I can combine permissions from both these predefined roles and create a custom role so they have the right permissions to do their tasks they should be doing on their projects on both of these services. And as I said, the policy is basically the binding of those three things. Who can do what on which resource? So the binding could be those members that we talked about. So we've got a Google account, any Google account, or a service account, or somebody coming from my organization as my workspace domain, or a Google group, and I attach them, I assign them a role, and then I need to bind it or apply it to my hierarchy in my organization. So the hierarchy, if you remember, I will have my organization as the top, and this could be my domain name, example.com, for example, my organization. So I can apply that binding to the top, to this particular identity. And I said, okay, you will be the compute instance admin for whole my organization if I want to apply it at this level. And in that case, anything underneath would inherit this permission. So this person, whatever I've chosen here, will be responsible for all my organization. Or I want, for example, if I have got in my hierarchy up, I leverage the capability of folders for maybe different departments or different teams. I can assign for a particular folder this particular role, and they will be responsible for all those roles inside that folder, whatever projects are underneath. Or I can go directly to a project and I say, okay, you are the instance admin of all the instances in my project, and I assign it there. Or if I want them to be more granular, and I said, okay, I just want you to be the instance admin of one particular VM, for instance, and I can apply it at a resource level. So I can apply at any of those levels in my hierarchy. And remember, the hierarchy, basically, we have permission will be with what you call inheritance. So the permission will be at the higher level, will be trickled down to all the resources inside of my organization. And this is an example how is it represented. So this is the policies represented by the policy object. So the policy consists of, like I said, a list of bindings, and the binding is binds all list of the members to a role. So with the role here, for example, it's the owner of the project, for example, and the members. I'm using a user, I'm using a group, I'm using a domain for the top level, and I'm using a service account. So all those are the members that I want to apply to. This is the role, this is the members, and this is the API method. So I've got what we call set IAM policy. This allows you to set those policies to your resources. You've got the get IAM policy, so allows you to get the policy that was previously set. So I can see, give me those what is applied already, or I can do what is called test IAM permission. So it allows you to test whether the caller has the specified permissions to a resource or not. So like I said, those resources are organized in that hierarchy, where the organization node is the root node in the hierarchy at the top. Then you have folders, you have projects, are the child objects of that, and the other resources are inside of the projects. So each resource has exactly one parent relationship. So you have parent-child, one-to-many, and then when you look at it from bottom to up, it will be a one-to-one relationship to a resource to the higher level in the hierarchy. And the service account. So service accounts, super important, super useful as well. So they belong, like I said, to an application. They might belong to a VM instance instead of a user. So they are used by your application to call the Google API or to call a service in Google Cloud, so that the users aren't directly involved either in the authentication process. So you won't need like a username and password to authenticate, and also it doesn't matter who is logged into that virtual machine for that particular task to happen. So each service account is as well is identified by again by as you would expect by an email address. They are associated with, like I said, not using a password, but rather with a key pair, and can have up to 10 key pairs. So you can basically rotate between those from security perspective, and basically, and to the reason why we have 10 is basically to facilitate this key rotation, which is managed by Google and done on a daily basis. You can take control of that if you wanted to. So we have like what we call custom service accounts that you can customize that. And basically these service accounts, like I said, they enable authentication, they enable authorization, because you can assign specific IAM roles to that service account to be able to do the tasks that they are meant to be doing based on that set of permissions. You can also, like I said, you can create external keys. If you don't want Google to manage that for you, you can create external keys to be used from outside Google Cloud, but they require that you manage the security of the private key and perform all the management operations like the key rotation, the retention, and all that kind of what is required to manage the keys. They are managed through the Cloud IAM API, so the G Cloud tool, and the Cloud Console as well. So you can manage those even there externally. You can also optionally use API keys to call certain APIs that don't need to have access. They don't need to access private user data as well. So that's you've got that level of customization. They are useful. The API keys are super useful in clients such as a browser, such as mobile applications that don't have a back-end server. So the API key is used to track API requests associated with your project for things like billing, for things like quotas, and things like that. And the beauty about service accounts is you can guys basically dice your services into what we call microservices. So you can define many of those service accounts in a project, and you can see in this slide that you can see the you can manage many different applications with different service accounts or microservices, if we want to call them that, in a single project, letting each microservice represented by its own service account. So each of those service accounts will assign them different different set of permissions, or different roles. So they will be able to do different things on different projects. So you might have microservice one, service account one assigned to microservice one. Service account one, microservice one might have cloud storage buckets, and that service account might need read-write access to that. But that service account, microservice 2, you might have another storage bucket, and you don't want that service account to have access to that. So you have a service account 2 who has the right permissions to access that storage bucket in microservice 2. So you will have kind of a lot of flexibility to kind of divide your authorization and authentication of those services with different service accounts. So this granularity is employed by specifying which service accounts are allowed to call which other services as well. So you might have like service account access in microservice 2, but it does have some sort of access to microservice 1, but not at the level, not at the same kind of power that service account 1 has. So you have a lot of control in that as well. And the way to do that, this is an example of how to the steps to do that. To use a service account in your application, first you create the service account via the command line from Cloud Shell or via the console. You then generate and download your credentials file, and then you can set an environment variable with a path to your downloaded credentials. And here in this example, what you see, it shows you the commands to set the environment variable in both here Linux and Windows. So both in there, so you can just export or set, and you can set just the path to those credentials. And you can then make an authentication. You can make the authenticated API request to your code using the using that. So the example code is you see here is in Python. Shows that if you don't explicitly specify credentials when constructing a client a client, that the client library will look for credentials in the environment variable. So we are calling that path to get those credentials in order to do that call. And also, Google uses credentials to identify your applications for, like I said, for quota, for billing, and also to authorize access to Google Cloud APIs, resources, and features. And you have, obviously, you have the Google Cloud libraries. Also, they use application default credentials, the ADC, to find your application credentials. So the credentials are checked for in this order. So it starts with the ADC, which is the Google the Google application credentials, and it will check in that environment variable, Google application credentials, and then in that environment variable, and if environment variable is set, ADC will use the service account file that the variable points to. Now, if that environment variable isn't set, then the ADC, the application default credentials, will use the default service account that was that the compute engine has been created with, or the GKE or the Google Communities engine has been created with, or App Engine, or whichever compute service you use to deploy your code. Could be Cloud Functions as well. Assuming that your applications run on any of those services, we're going to use the default service account that comes with them. If neither the environment variable nor the default service account can be found, then it will throw an error, basically. So the example that here that we see demonstrates using Python to basically implicitly find the credentials, assuming that either the environment variable is set or the application is running on, in this case, on Compute Engine, GKE, App Engine, or Cloud Functions. So this is how the application default credentials used to authenticate to your applications. And obviously, best practices, top of the list, principle of least privilege. This what you can be using either predefined roles or custom roles. Rotate service keys, manage user service account keys if you have chosen to do that. Don't check in service account keys to source code. Don't hard code those in your code. You've got the tools to audit, so you've got cloud audit logs to do those, to check any changes happened on a regular basis to your IAM policies. Whenever possible, set organization level IAM policies to grant access to all your projects, and this will be protecting you against errors that happen. So if you have like a set of policies that applies to all your projects, do it at the higher level. Don't try to go to each of those projects and applies them over and over again. This kind of process is kind of prone for error. It's very, very tedious. It's not very, very practical. So this is another one. And grant roles to Google Groups when possible. So instead of, let's say you've got a group of users who are part, let's say, of the networking team. So instead of when you have like a new users joining your organization from your networking team, instead of going to Google Cloud Console and each time a user comes in, you basically give them permissions as on that user level. Instead, use the Google Groups on your cloud identity or workspace. So create a group for the networking team. When you create that, you get an email identifier for that. So give permissions to the group. So if a user comes in, you're gonna add the user on the workspace or cloud identity to that group, and automatically they will inherit the permissions of that group because you assigned the roles and permissions to that user on the Google console. And we did an example of that in our previous sessions of how that works between the two. If that user leaves the company, changes team, I can just remove them from that group. All the permissions that they should have, they get revoked automatically because they are set at the group level. And this is the from best practice perspective. Auth 2.0 to access resources on behalf of a user. It is generally best to use service accounts for obviously authentication to, like I said, to Google Cloud APIs. In some cases, you might want to to access a resource on behalf of a user. So those use cases where you might want to access resources on behalf of a user include your application, for example, needing access to things like BigQuery datasets, for example, that belongs to your application users, and your application needing to authenticate as a user to create projects on their behalf. You can use what we call OAuth 2.0 protocol to access resources on behalf of a user. So what happens in that case, your application will request access to the resources. The users will be prompted for a consent. And if consent is provided, the application can get those requests, those credentials from an authorization server. And then the application can then use those credentials to access resources on behalf of that users. And the consent is depends of that application that you are using. There are different applications that you can do in there. Also, we have what we call identity and aware proxy. This is another service in GCP that controls access to your applications running on Google Cloud. The way it works, basically, it verifies the user identity, and then from that identity, it determines whether that user should be allowed to access or not. So it is basically like you can call it like a centralized authorization layer for your application that sits on Google Cloud. So it has an application level access control instead of using things like VPN or firewall rules and things like that. So you set those application level access control on Cloud IAM, and basically this is how it works. So you will have the user coming to Cloud IAM. So they are protected by IP. They can only be accessed through this proxy by users in groups with the crow. If they're given the right Cloud IAM role, they will be able to access Cloud IAM. And when you grant a user access to an application or a resource by IAM, they are basically subject to this fine-grained access control implemented by this product, without the need of a VPN or let's say firewall rules or things like that. So the IAP, this is what is doing the authentication and authorization. So it will check the user. So the user will log in. It will check their credentials. Are they allowed to access? They authenticate them, and then gives them what kind of authorization they are allowed to my application that sits maybe on a virtual machine or on my GKE cluster or whatever that might be. So in this case here, we can use App Engine as well. So here we are looking for the access to my App Engine application in this case. And also you can use not just App Engine. I can use Compute Engine as well, or Kubernetes as well. It works in the same way. So it does authenticate to the user first, and then it will check the authorization level to my application that is deployed on a Compute Engine or a Kubernetes cluster in GCP. And to ensure that the security of the application, basically just make sure that you configure your firewall and load balancer to protect against traffic that is not allowed to access. So let's say you've got on-premises users, the only ones that can access your application on Google Cloud. You will have basically the source IPs. You can do a firewall rule, and you can specify only this like source IPs I'm allowed to use Cloud IAP. So I can set that. And once they hit the IAP, I go through that authorization and authentication process that we've seen in the couple of slides ago. So, and the other one is use signed headers for API for App Engine standard environments that uses the API. So that's another one that is best practice. So use signed headers for the App Engine standard environment uses API. And the identity platform, this is another one that provides authentication as a service. So the identity platform is a customer identity and access management platform for adding identity and access management to applications. So I can authenticate using third parties. So it provides authentication as a service that your developers will be accessing via a set of SDKs. It can be used to support authentication methods like OpenID Connect, SAML, email, and password as well. You can use your phone, as well as a range of identity providers like Google, Facebook, Twitter. You can use those as your identity for authentication as a service as well. So differences between identity platforms and Firebase authentication, because that's what developers they use, the Firebase authentication. So the identity and Firebase authentication, from functionality perspective, they offer similar things. They both allow you to easily sign users in your application by providing backend services. They provide SDKs. They provide all the UIs, the libraries, all those kind of stuff. But the identity platform, they offer additional capabilities. They are designed for enterprise customers. So when you use things like OpenID Connect and SAML authentication, you will have multi-tenancy support. You can use the identity-aware proxy integration, and it gives you a high level of SLA as well, of uptime SLA as well. The identity platform is completely compatible with Google Cloud and all the Firebase products. And if you are currently using Firebase authentication and you upgrade to identity platform, your application will continue to work with existing Firebase services with no issues whatsoever. And let me just show you here quickly an example of this authentication. So let me share my screen quickly. And what we're going to be doing here is going to the console. And we're going to look at the authenticating with adding user authentication to an application, basically. So we look at a Python application that we're going to provision very, very quickly here. So I'm going to go to Cloud SDK, Cloud Shell. And where I'm going to go, I'm going to clone a repository here. And this is like a case study application. We're going to do it, deploy it very, very quickly. And then we're going to add authentication to it. And you're going to see how that works in a second. So let me get the code for this Firebase application. Okay, and then I'm going to cd to folder where I want to application is. Let me make this a bit bigger here. And this is where the directory where my sample files are. Okay, that exists. So I'm going to cd to that. Let me just clear this. And I'm going to configure this application. So here, I'm going to create an App Engine application, create a storage bucket, create two environment variable for my project and for my storage for my project for my storage buckets, and then I'm going to create a virtual environment for Python 3, activate it, install it, create my entities in the data store database, and then run the application after that. So it is installing the Python libraries. I've set here the storage bucket environment variable, the project environment variable, entities in Cloud Data Store database, and then I'm printing out the project ID that I'm using at the end here. And then I can run my application now. Python run server py. What I can do, I can preview that. So just to show you. And this is my application running. So if I want to take a test, for example, it's not asking me for any authentication or create a question or anything. So there's no authentication involved in this whatsoever. So what I'm going to do to this application, I need to add the authentication. So let's go back to the console and see how we're going to do that. So I'm going to have a look at the file and open the editor to see my code. Let me see my directory there with all my. And then Firebase. I'm going to see where is my file that I'm going to be adding authentication to. Start quiz. That's my quiz application. Web app. Static. There's an index file. And you can see the code in there. When it comes up shortly. So this is my index file. And this is in Angular JS. It's a single page application SPA. So we can see here when it comes up. Give it a second. I just want to show you the what the code looks like in this file. There you go. So this is my index file. This is for this is where I open my application. This is basically what is rendering the HTML file. And these are all the scripts. You can see Angular here, Angular root, the quizzes module, and so on and so on. This is the login. This is what I'm interested in. The QIQ login GS. This is the file that is of the interest to me. So this is what I want to customize to have logging to my application. So if I go to the under authorization, I look here. You have a look at this login file. Look at the template first. This should have the components for login. So if I open that, yeah, if I log in here, you can see the form control. I can see email, password, login button in there, logout button in there. So this is where the template that's used for this login GS. So if I go to login GS, so this is what allows the user to log into the application. So I can open that. There you go. There you go. Login components. This is entering the template file that we've seen. So you can say the login, the logout, the user ID, who's logged in, the user email, and if there's a failure, it will tell you that it's failed. So to configure that, let me just go to identity, enable identity first of all, the identity platform. So if I select identity platform here, what I will do, I will enable that. And here we're going to use the authentication as email and password as our authentication mechanism in this case. Enable. It's failed on me. Let me share the second screen where this is enabled. Chrome tab. second. Enablement is taking time, so give me a second here. It's taking time to enabling this identity platform, so I'll be able to use email and just refresh here. There you go. I think it's done it this time. And what I'm going to do is add a provider here. Provider is, this is the ones that we've seen on the slides. So I'm going to use email and password in this case. I'm going to enable that. And I'm going to add a domain. My domain is going to be the one from my application. Let me show you that. So I want to authenticate this application. So I'm going to bring the URL from it and go back to my identity, add that domain. Okay, 1 second, add. There you go, this time it worked. So now I've added that. The other thing that I can do here is, so I've enabled the username password here. I've added the domain where I want the authentication to happen. Now I added the authorized domain for my application. So I can just save now. And I can add user in this case. So I can go in the users, add user, let's say is, I don't know, test one at example.com and password 123 ABC. Okay, so I've got authentication by username, by email and password set up. So I've got, if I go to refresh this one now, and let's say I want to take a test. Refresh this page. Come back to my application. Application setup. Now I'm going to copy this authentication from here and to take it to my this snippet and take it to my authentication file that we've seen earlier. So let me switch back to that. So I've got the authorized domain, I've got the API key, I've got them in this snippet. I'm going to copy it and go back to my console. Share. Okay. I'm going to go to my file here, my index file. Yeah. And I'm going to put that right up before the script header. I'm going to put it in there. There you go. Now my authentication now is set up on my application. I can save this file. I can switch back to my application. Quiz. Can refresh that. If I try to log in with any user at any password, try to log in. Login failed. The user that I created earlier was test1. Test1 at example.com. Password was 123 ABC. Go. There you go. I've logged into my application with the right credentials. So if I want other users, I'm gonna need to basically create them with their corresponding passwords, and they will be able to authenticate. And yeah, so this is what I've got for you today. Just right at the right time in there. So let me see if there's any questions. In the chat, maybe. Right. Let me switch back to my slides. Can't see any questions in the chat. You can contact me on Twitter or LinkedIn if you have anything GCP related. Our next session is going to be a study jam, so you will have we'll have to do some labs. Watch out for the information about that. Register to the channel to keep informed by our awesome sessions. The on the digital days. All the best. Thank you, and see you on the next session. Thank you. Take care. Assalamu alaikum.